Standard toggle wall switches and timers are not typically underwriters' laboratories, or all rated for 125 volts DC. Derating a switch for use at a higher voltage than its rating is not recommended as it could pose a safety hazard. National Electrical Code, or NEC, Article 404.9 B prohibits the use of equipment in a manner that is not approved for the voltage and current. The recommended approach is to use a relay with a 125 volts DC coil. Install a relay with a 125 volts DC coil and appropriate contacts. Wire the relay so that the 125 volts DC backup lighting is connected to its contacts. Control the relay coil with the 120 volts AC wall switch or timer. The advantages of using a relay are firstly, electrical isolation. The relay provides electrical isolation between the 120 volts AC control circuit and the 125 volts DC backup lighting. Secondly, safety is improved because it ensures that the wall switch or timer is not directly exposed to the higher 125 volts DC voltage. Thirdly, by using a relay, you can maintain compliance with underwriters' laboratories or all safety standards. Additional considerations include contact rating. Ensure that the relay contacts are rated for the current draw of the backup incandescent lights. Also, consider using our relay with arc suppression features to prevent arcing and potential damage to contacts. The relay should be housed in an appropriate enclosure to protect it from dust and moisture. While derating a switch for use at 125 volts DC may seem like a possible workaround, it is not recommended as it violates underwriters' laboratories or all standards and poses a safety hazard. The preferred approach is to use a relay with a 125 volts DC coil to safely control the backup lighting. This method ensures electrical isolation, safety, and compliance with National Electrical Code, or NEC codes. In selecting the right relay, it's important to understand several key aspects. You must first consider the coil voltage. The relay coil voltage should match the control voltage available, which in this case is 125 volts DC. Relays are available in various coil voltages such as 5 volts DC, 12 volts DC, 24 volts DC, 120 volts AC, and 240 volts AC. Make sure to choose one with a 125 volts DC coil. Secondly, look at the contact rating. The relay contacts must be rated to handle the voltage and current of the load you are switching, which is the 125 volts DC backup lighting. Check the relay's datasheet for its maximum voltage and current ratings for DC loads. Ensure these ratings are higher than what your backup lights require. For example, if your backup lights draw 2 amps at 125 volts DC, choose a relay with a contact rating of at least 2 amps at 125 volts DC, but preferably higher to provide a safety margin. Thirdly, consider the number of contacts. Relays come with different contact configurations such as single pull single throw, or SBST single pull double throw, or SBDT double pull single throw, or DPST and double pull double throw, or DPDT. For this application, an SBST or DPST relay would be suitable. An SBST relay simply opens or closes one circuit, while a DPST relay opens or closes 2 circuits simultaneously. Choose based on whether you need to switch 1 or 2 wires of the 125 volts DC circuit. Fourthly, examine the relay type. Relays are available in different types such as electromechanical relays, or EMRs, solid-state relays, or SSRs, and reed relays. EMR are the most common type and use a physical coil and contacts to switch the circuit. SSR use semiconductor devices to switch the circuit and offer faster switching speeds and longer life, but may have higher voltage drop. Choose an EMR for simplicity and cost-effectiveness, unless you need the specific advantages of an SSR. Fifthly, factor in the mounting style. Relays come in various mounting styles such as PCB mount, DIN rail mount, and panel mount. Choose a mounting style that is appropriate for your application and the enclosure you are using. DIN rail mount relays are convenient for use in control panels, while PCB mount relays are suitable for mounting on circuit boards. Sixthly, include surge protection. Inductive loads such as relays can generate voltage spikes when they are switched off, which can damage the control circuitry. To protect the control circuit, use a flyback diode across the relay coil. The diode suppresses the voltage spike and protects the switching device such as a transistor or switch. Seventhly, look for terminal connections. Relays come with different types of terminal connections such as screw terminals, spade terminals, and solder terminals. Choose a terminal type that is easy to use and provides a reliable connection. Screw terminals are a good option for general-purpose applications. Finally, make sure to read the datasheet. Always read the relay's datasheet carefully before using it. The datasheet provides important information about the relay specifications, ratings, and operating characteristics. Pay attention to the voltage and current ratings, coil voltage, contact configuration, and other relevant parameters. By considering these aspects, you can select the right relay for switching your 125 volts DC backup incandescent light safely and effectively. In addition to choosing the correct relay, proper wiring practices are essential for safety and reliability. Firstly, disconnect power. Always disconnect the power supply before working on any electrical circuit. This prevents the risk of electric shock and potential damage to equipment. Use a multimeter to verify that the circuit is energized before proceeding. Secondly, use appropriately sized wires. Use wires that are appropriately sized for the voltage and current of the circuit. Refer to the National Electrical Code, or NEC, tables to determine the correct wire size for the application. Using undersized wires can cause overheating and potentially lead to a fire. Thirdly, make secure connections. Make sure all wire connections are secure and reliable. Use appropriate connectors such as wire nuts, crimp connectors, or terminal blocks. Ensure that the connections are tight and properly insulated to prevent short circuits and electrical hazards. Fourthly, insulate all connections. Insulate all wire connections with electrical tape or heat shrink tubing. This prevents accidental contact with live wires and reduces the risk of electric shock. Ensure that the insulation is rated for the voltage of the circuit. Fifthly, follow polarity. When wiring DC circuits, always observe the correct polarity. Connect the positive wire to the positive terminal and the negative wire to the negative terminal. Reversing the polarity can damage the equipment and create a safety hazard. Sixthly, protect the wiring. Protect the wiring from physical damage by routing it through conduit or cable trays. This prevents the wires from being crushed, cut, or exposed to moisture and other environmental factors. Seventhly, ground the equipment. Ground all metal enclosures and equipment to provide a path for fault current. This helps to prevent electric shock and reduces the risk of electrical hazard. Refer to the National Electrical Code, or NEC, for grounding requirements. Eighthly, label the wiring. Label all wires and connections with clear and durable labels. This makes it easier to identify the wires and troubleshoot the circuit in the future. Use wire markers or labeling machines to create professional-looking labels. Ninthly, test the wiring. After completing the wiring, test the circuit to ensure that it is working properly. Use a multimeter to check the voltage and current levels. Verify that the relay is switching correctly and that the backup lights are turning on and off as expected. Finally, inspect the wiring. Inspect the wiring regularly to ensure that it is in good condition. Look for signs of damage such as frayed wires, loose connections, and cracked insulation. Replace any damaged wiring immediately to prevent electrical hazards. By following these wiring practices, you can ensure that your 125 volts DC backup lighting system is wired safely and reliably. Additionally, consider the following safety precautions to ensure a safe working environment. Firstly, use personal protective equipment or PPE. Always wear appropriate personal protective equipment or PPE when working on electrical circuits. This includes safety glasses, insulated gloves, and appropriate clothing. PPE helps to protect you from electric shock, burns, and other electrical hazards. Secondly, work in a well-lit area. Work in a well-lit area to ensure that you can see what you are doing. This reduces the risk of making mistakes and helps to prevent accidents. Use a flashlight or work light if necessary. Thirdly, keep the work area clean and organized. Keep the work area clean and organized to prevent tripping hazards and other accidents. Remove any clutter and debris from the work area. Store tools and equipment in a safe and secure location. Fourthly, use insulated tools. Use insulated tools when working on electrical circuits. Insulated tools help to protect you from electric shock. Make sure that the tools are in good condition and that the insulation is not damaged. Fifthly, avoid working alone. Avoid working alone on electrical circuits. Have someone nearby who can assist you in case of an emergency. Make sure that the person is familiar with basic safety procedures and knows how to shut off the power in case of an emergency. Sixthly, know the location of the emergency shut-off switch. Know the location of the emergency shut-off switch so that you can quickly shut off the power in case of an emergency. Make sure that the switch is easily accessible and clearly labeled. Seventhly, follow lockout/tagout procedures. Follow lockout/tagout procedures when working on electrical equipment. This involves disconnecting the power supply and placing a lock and tag on the disconnect switch to prevent someone from accidentally turning on the power while you are working on the equipment. Eighthly, be aware of your surroundings. Be aware of your surroundings when working on electrical circuits. Watch out for potential hazards such as wet floors, overhead power lines, and other electrical equipment. Ninthly, avoid distractions. Avoid distractions when working on electrical circuits. Turn off your cell phone and other electronic devices. Focus on the task at hand and avoid any activities that could divert your attention. Finally, if in doubt, ask for help. If you are unsure about any aspect of the electrical work, ask for help from a qualified electrician. It is always better to be safe than sorry. By following these safety precautions, you can create a safe working environment and reduce the risk of electrical accidents. In conclusion, switching 125 volts DC backup incandescent lights using a standard 120 volts AC wall switch or timer requires careful consideration of safety and compliance with electrical codes. Standard wall switches are not typically rated for 125 volts DC, and derating a switch for use at a higher voltage than its rating is not recommended. The preferred approach is to use a relay with a 125 volts DC coil to safely control the backup lighting. This method ensures electrical isolation, safety, and compliance with National Electrical Code, or NEC, codes. In addition to choosing the correct relay and following proper wiring practices, it is essential to observe safety precautions to create a safe working environment and reduce the risk of electrical accidents. Always disconnect the power supply before working on any electrical circuit. Use appropriately sized wires, make secure connections, insulate all connections, follow polarity, protect the wiring, ground the equipment, label the wiring, test the wiring, and inspect the wiring regularly. By following these guidelines, you can safely and effectively switch 125 volts DC backup incandescent lights using a standard 120 volts AC wall switch or timer.